One of these is from the World Trade Center dust, that sphere that I just showed you. One of these plots is from Thermate, so one is just the EDS signature for Thermate. Now I ask you, which one is which? This data has never been shown before. These data, I should say, data is plural. And I must admit, I lost sleep when I first saw Building 7 come down and did the timing on it, because I thought, man, this is a smoking gun for somebody getting into this building, never hit by a jet, doing it. It looked so much like a controlled demolition. But now we have what I consider another smoking gun. I think Alex used that term as we discussed this on the radio. And now you can see the plot. You see that iron, and it's very clear. Sulfur and aluminum. That's the signature for Thermate. Iron, sulfur, aluminum. Folks, you really, there are some differences, but you can't tell which one is which. I mean, they have the same, the signature for Thermate is there. And this, by the way, this method is what is used by investigators when they're looking for thermite, sulfur thermate residue. They use the same EDS method, energy descriptive spectroscopy. There you have it. So you want to know, I really can't remember because they're so much the same. I have to go out. Oxygen is different, but that doesn't really tell you too much because it depends on like the stoichiometry of the mix. But that is a good point. My stoichiometry was not as good as whoever did this, and so the one I did is this one has more oxygen left over.
This is the tank.
No, I think actually it's from the, I used iron oxide and aluminum powder. When I put those together, you have to get the stoichiometry just right and so on. So there is a small distinction there. That's something that we'll look at more. Okay, now here is a comparison between this is the World Trade Center sample, and this is steel. Now you can see the distinction very clearly, can't you? These are not, these droplets in the World Trade Center dust are not molten steel. They don't have the same chemical signature. See, I kept the World Trade Center dust on the right in both of these. So here's the World Trade Center dust. This is the Thermate. Remarkable. The match is right on.
It's arson.
It is definitely arson.
Coal busted.
Now, I'm going to educate you a little bit. It's a little more complicated in that if you look at a small spot on one of these spheres, that big sphere actually, look at the sulfur peak on that. So if you look at different spots, you pick out things you might not have seen before. In particular, copper shows up in this. Copper, a lot of copper. Copper oxide is used very typically in the thermite reactions because it gives you more energy actually than iron oxide. So it's very typical, and we do indeed see copper in this one. And a lot of sulfur. The sulfur is unmistakable. I just want to show you, as you move around and home in on different spots, you will see some variation in quantities, and some metals that are in small amounts will show up. The copper shows up. Okay, now this shows how I went after the little spheres that are too tiny to see by eye. So I decided to use a magnet and a plastic magnet. This is actual dust from the World Trade Center. See? You just simply, the magnet pulls it out of the dust up to the top. The magnet does not touch the dust or the iron-rich component. And we simply pull it over to the side. And then I pulled it over close to the edge of the bag. I have a pedestal with this carbon tape, and that microphone picks up too. And when I push this then onto the iron-rich component of the dust, It adheres to my little pedestal. Now I put it in the electron microscope. And actually, I should give credit. I'm not the one running the microscope. It's actually a student who is doing that, who's actually running it. So you can see this magnet just pulls it out. As we concentrate, then the iron-rich component. And I just thought of that technique myself. Then when you look at this iron-rich component in the dust, you do see some dust particles that come along. And when I first saw it, look at all those little spheres. See? Some of them are quite perfect, others are rough. Let's see, that one's quite rough. And there's about 2 dozen spheres in this view, if you look and count. A lot of these. Okay, this is now at much larger magnification. That is a higher magnification. 2 spheres. Let me go back for a minute. That's these 2 right here. This is at, what is that, 102 power. We go to 1638 power with the electron microscope. They're quite pretty, actually. The structure is a little different. I call this, actually the student called this sphere Y because it looks like yarn wrapped into a ball. And this was sphere 4, turned out.